Welcome back to another 3D comparison video. I received the following comment for my 3D Generative AI video regarding VoltBoy. So how do you make the body from generated mesh? And if you're going to take a look, this will be the video. I will jump directly to the CSM AI platform. And if I will scroll down over here, I will see that the VoltBoy model will be loaded over here. So let's see, I will have this downloaded. As we can see on the platform, we can have it downloaded as an OBJ, a GLB, a USDZ, and an FBX. Now, for computer-aided design, OBJ will be the file format that will be compatible with most solutions. We're going to see that SolidWorks will import OBJ directly, Fusion as well, but with CATIA, we're going to need to do some changes over there. Okay, so I already have the OBJ loaded over here. If I will find it over here, it will be the mesh OBJ. We're gonna see the albedo texture of the VoltBoy. So let's get started initially with SolidWorks. So I will drag and drop the mesh over here. We're gonna see that the model will be loaded, but keep in mind that this will be loaded as a graphic body. We see that I receive a notification that we can have this further edit within the mesh modeling workbench over here. And if I will enable a tool will also notify us that the model contains a graphic mesh. And as we can see, if I will click OK, we're gonna see that we're gonna have that, let's say, mesh on the interior. But keep in mind that we cannot work directly with it within SolidWorks, since this is just a graphic representation. If, for example, I will create a plane, we're going to see that this will be the top plane. If I will go over here to Feature, Reference Plane, now we're going to see that by default I have a plane over here at 9 millimeters. If I will type in 1, we're going to see that even 1 millimeter will be, as we can see, very far off from the model. So that means initially we're going to need to scale the model, because one of the problem of AI generated meshes is that they are not at scale. So it's not the same as 3D scanning, which will give you the accurate scale of the model. So I will jump over here within the mesh modeling and I will have this scaled. I can select the element and let's see, I will scale this 10 times. I click OK, starting from the center. And now from the top plane, if I will go to Features, and if I will go to Reference Plane, we're going to see that 9 millimeters will be all the way over here. Or if I will flip it, it will be on the lower section over here. So if I will go with something like 8 millimeters, it will be over there. Now I have this newly defined plane on the bottom of the figurine. So if I will jump over here and I will draw a sketch, for example, maybe I want to draw a circle. I'm going to make a circle that will be mostly the same diameter as the bottom platform over here. And if I will go to Features, I will see that by default only Extrude Boss will be enabled over here. So we can just add geometry. We don't have the possibility to cut geometry from the model. This is because we still have that added as a graphic element. So in order to cut that section from the part, so to make it a solid body to work with it, I'm going to jump within the mesh modeling tool and we need to convert the mesh. So we are going to use the first feature over here, convert to mesh body. We're going to select the body. In this case, it will be the 3D model generated by the AI tool. And as you can see, we only have the possibility to group facets into faces, but I will not check that. As soon as I will click the OK button, Solid will no longer be able to use that UV texture mapping. So we have the albedo texture over here. Within the newer version of CSM, they also have this a little bit better unwrapped. So I will make a video regarding that as well. Now, we have the imported element over here. And now if I will go within this section, within features, we're going to see that the extrude cut, for example, also is a viable option. And also the other elements regarding model subtraction. So if I will go now with an extrude cut, I will also hide those edges. And we're going to see the mesh will look like this. And if I will cut 10 millimeters from that plane downwards, we're going to see that the model has been trimmed over there. And now on the resulting edge, we can further go along, for example, with a fillet. In this case, I will go with something really small, something like 0.1. And if I will select that, we're going to see that since we have the tangent propagation on, SolidWorks will manage to do that selection. And if I will click OK, we're going to have that, that fillet added. And again, if I will go with shaded, we're going to see how that will look. Keep in mind that over here we also have the graphic representation enabled, which is the one defined by triangles. I can always hide it, so I can right click and have that hidden. But also we're going to have the imported one, which again will be tessellated, just like the other one. And if I will try to hide this, everything will hide because we are within the same solid body over here. Okay, so this is how you can work within SolidWorks. Now I want to jump within Fusion, and we're going to see how we can work over there. And later we're going to jump within CATIA, so I want to present all the workflows. So I have Fusion ready over here. I just need to go to Insert, and I will add this as a mesh. As we can see, since this is an OBJ file, Fusion, just like Solid, will be able to load this directly. So this is something that CATIA V5 cannot do, only within the newer 3D Experience version. I can insert that mesh. I will say that I want to select it from my computer, and I can just copy paste the mesh OBJ file over here, and also the texture will automatically be linked. So back to Fusion, select from computer, just paste that over here. As we can see, this is within my download folder. I will click open, and we're going to have the mesh model loaded over here. By default, this will be differently orientated than within Solid. We see that Fusion uses Z as the top axis by default, while Solid will use the Y axis. So that's a difference. We can just have this rotated, or if you want to, we can input numeric values over here. For example, as I move that, I rotated that on the X axis, I should maybe add that 90 degrees, so it will be a perfect angle over there. Now I can click OK, and again we see we have the texture, just like we had it over there within SolidWorks. And this will be the same workflow. So underneath mesh, we're going to have the possibility to go to modify, and we can do that convert mesh. So this will be the feature. Just like within Solid, I can select the body. We're going to receive a warning that the mesh has more than 10,000 triangles. Therefore, the calculation may take a certain amount of time. We also have multiple methods over here. So we have the first one, which is faceted. As we can see, this will convert individual faces on the mesh body to individual faces on the new solid or surface body. We can also go for a prismatic, but usually prismatic is for elements that are not that freeform or organic. And we can also enable organic, and as we can see, this will be a better fit. If I will go, for example, even with faces, we should be able to convert this mesh. So I will click OK. We're going to see how Fusion now will take some time to process this OBJ. So it's not that fast as SolidWorks, but it's also not that slow. As you can see, Fusion minimize. So I have the browser over here again. But if I will maximize Fusion again, back in the background, we have that mesh converted. And as we can see, we're going to have the same triangulation over here. We can also do a remesh, or we can use the reduce tool, which will decimate this, so it will no longer be that complex. But for this case study, this will be more than suited. Again, if I want to, I can change this to be shaded, just like we did in SolidWorks. And I will no longer see those faces over here. And now if I will jump back to the solid workbench, if I will enable the origin and I want to construct a plane, let's see, I will type this at 1 millimeter. Since the model has not been scaled, I should scale that because now we see that the distance of 1 millimeter will be like that. I will just add this to be minus 0.2, for example, or maybe something like 7. And I want to draw a new sketch in order to cut the bottom part over here. So as we can see, with 0.8 we're gonna go all the way to the bottom cylinder, and I can define a new sketch on that plane. Okay, let's see, should be able to do that, but as we can see the viewport is acting a little bit weird, and I think I know the main reason for this is because the model is so small. This is something that within SolidWorks I added that scale for the model, because otherwise we would have the same problem with the camera calibration over here. So let's see, I will try to define that new sketch onto that plane. If it will again be a little bit laggy, I will just scale the model. But if I try to select the sketch over here within a viewport, since we are so zoomed in on the model, we see that Fusion acts a little bit weird. But I will just select it over here as a plane 1 directly within the product tree, and that will fix this, even though our model is really tiny. So as we saw, something like 2 millimeters. And I can define the radius over here that I want to cut. I will just make it like this, and afterwards, if I will go and do an extrude cut, so I want this to be cut, I will select the profile and I will go downwards in order to cut that. You're gonna see that Fusion processed this a little bit slower than SolidWorks. Maybe it does require a little bit of decimation on the model. Okay, so I see that there are some problems. I still want to do that cut because it should process this. I have worked with more complex elements directly within Fusion and it worked, but I think the main reason is that the model is not scaled properly, and Fusion doesn't really work really good with small elements. So I will just cancel this for now, and I want to scale the model. Okay, so I managed to cancel that. I will jump back within the mesh, and under modify we have the possibility to scale the mesh. But now, since we already had that converted, I will just scale directly the solid body, because we no longer have that mesh over here. So I will search for the scale underneath the solid body, and for this entity I want to scale this again with a factor of 10. I will scale this uniform, and I can click OK. The model should now be scaled. We see that within the viewport it also increased. And let's try to do that editing again. Again, when Fusion is working, it's a little bit weird that it will go within the taskbar, and you need to enable it again. So that's something that I noticed. I also have my laptop on silent now, so maybe it's not processing that well, because I want to make sure that you can hear me better. I will just create a sketch, and I will start over here with the origin, for example, the X and Y plane. And if I will do a cut over here, you see that now that will have 7 millimeters extrude. I will select it, go a little bit downwards, and we're gonna see how that cut will update. And we see within the preview that our character will no longer have that section. Okay, a little bit laggy over here. I will just move this a little bit upwards. click OK, and that should do the cutting. And if the cutting works, because it should work, we're gonna see how important for Fusion is to work at reasonable dimensions. So not very tiny like we had it before. Again, Fusion went into the bottom tray, but when we come back over here, we see that we have that solid cut exactly over there, and we can start again with fillet just like we did within SolidWorks. So I can do a fillet. This should go tangent. We see that is set to tangent 0.2, but we see that the tangency wasn't taken by the fillet. So let me just make sure that the edge has been properly selected. Okay, let me enable the visual style so I can see the edges as well. As you can see, there are some struggling over here, so edges. It's quite weird that the tangency will not propagate because we have this set to tangent. So apply tangent. If I will go to curvature, again, it will not work that well as in SolidWorks. Maybe I'm doing something wrong, so let me know in the section below what exactly should I do in order to have that filleted just like we had within SolidWorks. Okay, and now for the last part we have CATIA V5. This is the software that most of my videos are, but as we can see by default I cannot use the OBJ file. Since CATIA V5 is a little bit of a legacy software, it's not compatible with this file format, even though the OBJ file format is old, so quite old. In order to have this open over here, I will have to convert this. So I will just use, for example, SolidWorks over here. I have the imported element, and I will move directly the one that has already been cut. So keep in mind, I usually prefer to use Blender because Blender will open that directly. But now let's see this approach with this one. I will go over here and I will save this as an STL. I will call this mesh on my desktop. Underneath the options, we can specify the resolution. So this is currently set to custom. We can go to coarse. This will do a decimation of the model. I will just leave it like this with custom for now. The output will be set to millimeters. If I will click OK, this should be called mesh on the desk. File will be created over there. And if I will jump back to CATIA, since now we have an STL, there are two methods that can load that STL file. I will use the one that is the most popular one, which makes use of digital shape editor. So maybe this is a workbench that is not available depending on your license. So I will go over here to import, and I want to import that from the desktop. I will go on the desktop and we're going to have the mesh over here, set it to open. If I will go with a scale factor of 1, this should maintain the same just like within SolidWorks. I will hit apply. We're going to have the model loaded, and again the same orientation. As we can see, we have the z-axis going upwards, just like within Fusion we have the z going upwards, but within Solid we have it on the y-axis. So if you want to change the orientation within CATIA, you can always use the compass. You can snap that automatically to the object. Right click, edit. You can add increments over here, and you can just have that rotated. For example, on the u-axis, 90 degrees, and now it will have the desired orientation. If you want to move it in regards to the default planes, you can also select it and you can move it around. So you can use those elements, and as we can see, now it's better aligned with that. Even though it was misleading, it's always a good idea to do that from the top. As we can see, if I will move my mouse over here, this will move it on both those X and Y axes, and I can better fit it. And now all that I have to do is position it a little bit upwards. So so something like that. Okay, and now if I want to work this within part design, I initially have to convert this. In order to transform this, I will go with a mesh cleaner to make sure that there are no corrupt elements, and there are no. The other softwares, so Solid and Fusion, managed to process this, and I'm sure CATIA will process this without any problems. I will go within quick surface reconstruction, and over here I will search for the automatic surface. I can select the mesh. I will leave this as a mean deviation surface for 0, 1. For the surface detail, we see that this will be set to 10,000. So Fusion did something similar. And I will click preview. Now CATIA will start to process. We see how fast this has been processed. But the mesh density isn't that high as the one that Fusion generated or Solid. If I will click OK, we're gonna see that this will be the mesh, the resulting mesh, so those surfaces. If I will select that, I can go to Analysis, Information. We won't have the exact number of faces of this one, but if I will click on the mesh, we're gonna receive the number of points that have been processed. So initially we had 66,000 triangles, and we see that the automatic surface with those parameters generated the following mesh. If you want to, you can always change this. You can go over here within definition and you can increase it. For example, I want the target ratio to be 95%. If I want to, I can set this to be full internal tangency. That is regarding the tangency of those surface. If I will now click preview, CATIA will process this again, and again we see that it processed quite fast, but still we don't have a highly dense mesh. But for this case study, this will be more than fine. Now we can jump within part design, and within part design we're going to search for the close surface. We can also do this within generative shape design, but I prefer to do it over here. Click OK, and if I will hide the surface, now we're going to have that mesh. I can move the compass so it will not block that model. And again, we can start working on the model. Since this is a solid body, I can do a sketch. So maybe I want to define a sketch on this X and Y plane. I will fit this. Again, I can create a circle just like we did in the other two CAD solutions. And I want to cut this on 2 millimeters on the top side, and we're going to see that the character will lose those legs. Okay, so this is how you can work with solid bodies, and I highly recommend that you give Common Sense AI tool a try, because as we can see over here, this is the original image, this is the segmented image, and this is the resulting model. In my opinion, it did a really good job. And there are also some tools, so we can either change the UV mapping. We see over here the UV remapping, and this is the original unwrapped. They have an update, and the UVs will look a lot better. So we can further process those within an image processing software, because over here this is almost impossible. As we can see, for the character, we have the face over here. We have the other eye over here, so they are quite all over the place. And it's really hard to work directly on this texture if you want to do some retouching. We can also retexture this and animate with AI. Okay, so Victor, I hope that you find this video useful, and also for the others. Let me know in the comments section what is your preferred CAD solution to work with models. Because for me, it has to be CATIA, because I have the longest experience with CATIA, but I like the fact that that Fusion offers really good freeform modeling afterwards, while SolidWorks offers a really nice environment and easy to use user interface. Okay, so that's it. Thanks for watching. See you in the next video.